test. Check test. 1 2.
1 2 check check. Check 1 2 check test.
Check test. Test 1 2.
Check. Okay, done.
Check test 1 1 2. Sound check 1 2 3 4 5 6.
Check test 1 2.
Check testing 1 1 2 1 2. Check testing 1 1 2 1 2. Check testing 1. Check test 1 2. Check testing 1. Check test 1 1 2. Shalom. Shalom. Check testing. Check 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 check. Check test 1 1 2 2 2 2 2. Check. Check, check, test. Test 1 2. Check, check. Check test 1 1 2 1 1 2. Check test 1 2. Check. Check testing 1 1 2. Check check 1 2 3 4 5 6. Check check testing 1.
will I build? What will I build today? Will it be beautiful, functional, or make a difference? Will it change the way we work, or simply bring us together? Whatever it is, it needs to be better. Better for business, for people. What will I build today? Will it be beautiful? What will I build today?
Fantastic. Check, check, 1, 2. Hey, hey. Check, check, 1, 2. Move these down for now. And I think you can go ahead and meet me on the desk. Otherwise, you might hear me cursing. Open that should not be open.
test. Are we live? All right. Everybody, welcome. Good morning to the final day of GIDS 2025. Give yourselves a round of applause. It's hard to believe that this incredible summit is almost over. It's the final stretch, but also it's a moment of reflection. Over the last 3 days, we've explored, debated, questioned, and built. We've reconnected with what makes us a community and what makes us so powerful. It's a shared love. It's a shared love of technology, a desire to keep improving, and a belief that what we build really matters. And everything you've gained at GIDS this year, this energy, the connections, and the learning, that's what you will take back with you as you get back to your lives. This week, we've explored what it means to be part of the tech vanguard. We've looked at the technologies, the practices, and the people who are shaping the future. As we look ahead, the path isn't really exactly clear. And that's what makes it exciting. AI is evolving. Architectures are shifting, teams are distributed, and dynamics are changing. But one thing remains constant: the value of the people who care about their work and care about each other. But GIDS just isn't about what you're here for these 4 days. It's about what you do after you leave. It's about taking what you've learned and using it to make a difference in your work, in your community, and in your world. And then when we look forward to meeting you again next year, same time, same place, right? To evaluate and learn what's working, what's changing, and what's around the corner. So as you engage with today's final sessions, think about how you can apply what you're learning into building connections, not just applications. Understand AI's risky yet revolutionary potential, building a more grounded, meaningful future, and honoring the giants whose shoulders we stand upon. Today, we'll also hear critical insights on building robust, secure LLM and agentic AI workflows, real-time strategies for combating SMS fraud, Gen AI microservices, structured connectivity, concurrency in Java, RAG crafting compelling architecture narratives, accessibility innovations through AI, and plenty more. Here's what's on the agenda for our final day. We'll start with the keynotes, and then after a coffee break, we'll dive into parallel sessions across 5 different halls. We've allocated a 10-minute break between sessions so you can move between the halls easily. Don't forget to check your summit guide and all of the banners outside for a full schedule and hall locations. You won't want to miss our grand finale this afternoon. At 5:40, we invite you to join us in this main hall for a special closing town hall session on Will AI Replace My Job? Our candid, high-energy panel will tackle the questions on everyone's mind about AI's impact on our industry with live Q&A and absolutely no sugarcoating. It's the perfect way to conclude GIDS for 2025 with insights you can actually see. Make sure that you grab a seat in this hall by 5:40 and be ready with your questions. Also, after the keynotes, the 2 keynotes, we are going to be doing a 15-minute A-Press giveaway. So hold tight because there's going to be free giveaways. All right, before we move forward, let's give a huge round of applause for our speakers who made this event so rich. Let's give them a round of applause. You've shared not just your expertise, but your time, your stories, and your energy. You've poured your hearts and souls into sharing your knowledge and inspiring us all. You've helped us see what's possible, so thank you, speakers. I'd also like to extend our thanks to our incredible sponsors who have made GIDS 2025 possible. That includes our platinum sponsors: Lloyd's Technology Center, Atlassian, Target in India, Zoho, Work in Finland, New Relic, Google Cloud, Twilio, Toast. Our gold sponsors: Apprise, Tesco Technologies, Neo4j, OpenText, Wells Fargo, EPAM Systems, Snowflake, Redis, AWS, and our silver sponsors: Zcoder, ImageKit, Tide, ThoughtWorks, Goldman Sachs, Couchbase, Arcesium, 7-Eleven Global Solutions Center, Delta Tech Hub, Okta, Amadeus, and our bronze sponsors: Pega, Walmart Global Tech, Kanini, and our state partner, K-Tech. Now, let's get down to making the most of our final day. And let's finish strong. It is my pleasure to introduce to the stage Mr. Scott Davis. Everybody give him a round of applause.
Thank you. Namaste, good morning, how are you? Good? Oh, wonderful. Thank you so much for being here. How many of you have been here all week with us? Show of hands, please. Thank you so much. Thank you so much. This is truly one of the high points of my year, getting a chance to come and speak to you. Dilip and Indu, we take these opportunities to have lunch together, to have dinner together. And I mention this only because this is my last day in the country. This is Michael and Kate's last day in the country. I was informed this morning that I ate the last Mysore masala dosa in the city of Bengaluru. So there's nothing here for me until next year when you can harvest more dosa so I can come back and enjoy it as well. Yeah? But the reason I bring up all of this is Venkat and I both live in Colorado. We live within an hour of each other. Michael and Kate live in Colorado. We live within an hour of each other. And so when they asked me to introduce Michael this morning, I said I would do it with great pleasure. It would be an honor because it's rare that you get to introduce such a dear friend. And that authenticity you see when we hug each other coming up on stage, that's because we're friends that have spent years together getting to know each other. I believe this is, my 15th year here as well, so I feel like in some way we've all gotten to know each other. So thank you once again for coming and sharing this moment with us. Please give yourself a round of applause. Now, I'm not going to speak much more because we have a professional magician on stage, but did you know that in addition to digital accessibility, I dabble a little bit in magic as well? I fancy myself a bit of an amateur magician. Michael, can I invite you up on stage here? Please, let's give Michael a big round of applause. Yes.
Thank you. Thank you.
Now, I don't want to steal any of your thunder, but will you join me in a magic trick here for a moment?
I would love to. Nobody ever shows me magic.
Oh, okay. Are we ready? Yes? Okay. Please, if you would, sir, oh, by the way, my name is Scott Davis. Thank you very much.
Pleasure.
Pleasure to
and
meet
we
you.
haven't met before. We've
never met. This is not staged. Okay, yes. So, Michael, what I'd like you to do, I'd like you to think of a card, if you would. Will you close your eyes, please? Concentrate. Are you concentrating?
Very hard.
Okay. I see something. So something's coming to mind. Okay, sir. Would you open your eyes? Is this the card you were thinking of? Michael is the author of Mastering Software Architecture. Yes.
Oh, thank you.
You can tell why they don't ask me to come on stage and do magic tricks, right? Yes, but what you have here is someone who is not only an amazing magician, but the author of Mastering Software Architecture. We know that to the uninitiated, to people who are unfamiliar with our craft, our art, that software can seem like magic. It can seem like, how is this even possible, especially in this age of AI? But then I have breakfast with my dear friend Brian Samboden, who's getting his master's in artificial intelligence from Harvard. And we realize that AI is not magic. It's science. It's facts. And so Michael has the incredible talent to not only bring you the magic of card tricks, but bring you the magic of software architecture as well. And he's able to show us that while it may seem amazing if you're not initiated, he is able to show you the magic of software architecture, and then you leave a little bit smarter knowing that this isn't a trick, this is our craft, this is our art. I've said too much already. Please excuse me from the stage. Give my dear friend Michael a warm round of applause. Thank you so much. Thank you very much.
Scott, bring it in. Thank you so much. Scott Davis, everybody. It has truly been a blessing to work both as a software engineer and a software architect and a DBA at times and so many other facets of our field while in parallel traveling the world performing professionally as a magician. And it gave me some really unique insights. It's taught me a lot of lessons because magic reminds us that more is possible than we might naturally expect. Magic is all about showing us what should not be possible and yet what is. And operating in that space for so long has changed the way I think about technology and architecture and people and teams and organizations and technology. Everything was largely covered by Scott in terms of my introduction. I like to think of myself as a holistic software architect because software architecture cannot exist in a vacuum. There's so many variables, there's so many considerations that we have taken into account. I am a speaker, I'm an author, I'm a magician, so many more things. But, Scott, you blessed me by performing a little magic trick. Let's actually explore this metaphor for a moment. I don't know if you've noticed, but here on the stage, I have a playing card impossibly balanced. See, this is one of the things that we do. Come on up, give him a round of applause. Oh, grab a handheld, it'll be all right. Oh, he's gonna wire up. No worries, while he's talking, I'll talk a little bit about this. Because we live in an age of information. It's a beautiful thing, it's an exciting thing, it's a terrible thing, and it can be both. But every now and again, we see something that seems like it should be impossible. But somebody's doing it. And we want to do it. And living in the age of information that we do, perhaps we can simply go online. We stand on the shoulders of giants, those who have faced our challenges before. And they share their experience, and we benefit from that. And sometimes we're able to follow in their footsteps. Now imagine for a moment what you just saw with that impossibly standing card. The answer is on Stack Overflow. Somebody says, oh, I'll tell you exactly what to do. Scott, we have some cards.
Yes.
Give them a mix, why not?
Mm-hmm.
Hand me two, hand yourself two.
Anywhere?
Anywhere,
Yeah.
it doesn't matter.
Okay.
You're going to hand me two, you're going to give yourself two, and it doesn't matter who gets what.
One for you.
Okay,
One for me.
perfect.
Another for you.
Ooh, I like my starting
for me.
hand. Pair of kings.
Oh.
And we can set the rest down on the corner. So we go online, and we look for that person who's faced that problem before. And follow along right here. You're just going to do what I'm going to do. You have a card there. You have a card here. Go ahead and right there. Perfect. Now, the accepted answer on Stack Overflow. Take the first card and flip the second card over.
I'm an amateur.
That is the work of a professional. I have no idea what that is. Step 2, accepted answer. 100 upvotes. You stand one like this, and then you lean another one on the side, so they're balanced. Go ahead.
Did I mention that I'm an amateur magician? Oh, this requires talent.
Lean the top of the T just a little more, so you're getting a little bit more downward pressure there. He's also got a good mentor. So far, so good. Step 3, dead simple. Take your finger. Your turn.
Do I make the noise as well?
If you could. Now, I don't know about you, but when I've gone to Stack Overflow and done these things, this happens sometimes. What did we miss? Whoa! I blew too hard.
Oh,
Got a gale force there. So maybe today you go to ChatGPT and it says, oh, you may have missed a step because ChatGPT has been trained on the entire World Wide Web. And maybe this person on the web, maybe what they did was on Stack Overflow, they left out a step, but other people reading it, they kind of got the inflection. So take one of your cards. ChatGPT mentioned to do that, and then you take your card, you flip the other one. Whoa, what's going on here? That's, do we have the AC on? That's okay.
yeah.
Stand one, stand the other, just like that.
So
Yeah, go ahead.
Yes,
Flip.
yes.
And you did the flick, right?
Oh, yeah.
Because ChatGPT reminds you to do the flick.
Yeah, yes. Yes, of course.
You do your little T.
I'm better at it. I'm
Yeah,
learning.
yeah.
I'm learning.
Well, ChatGPT gave you extra context, and then you do that. Now maybe we try a different model. In this, because why not? They're heavily subsidized. Let's take full advantage of their billions and billions and billions of dollars on compute. And then you learn what the real secret is. There was a step that was missing out in all these different places, and it all comes down to how you do that flick. You see, I don't know if you noticed, I was holding it closer to the center, and I was flicking pretty hard, and it was getting just the tiniest bend.
Oh, okay.
Now you know.
Now.
So go ahead, get yourself set up. You're going to do the little flip
Hold
maneuver.
it in the middle. Strong.
You've done your flip maneuver? Yeah, so you got
Yes.
a nice little bend in there?
Yes.
And that's the thing. So once you've got that bend, you're going to take the cards, you're going to, wow,
The wind up here.
I'll do that. My finale is going to be very difficult if it keeps being breezy. And then you've got your bend, you stand the card up, and there you go.
Are you with me?
You know, maybe it's the cards. Maybe I have the good ones, and you have the bad ones. Trade me, because you did give me a pair of kings. So go ahead, we'll do the flick.
Yeah. Okay.
We'll do the flip. We'll do the everything. And we'll go like that.
What could possibly go wrong?
No pressure.
I know.
Tick-tock, Scott.
Tick tock. Okay. And then a flick,
Then a little tap,
a little tap.
and off. There must be something more. There must be something more foundational going on that is missing in the easy answers. Thank you, Scott. Give him a round of applause. I'll gather these things up, clean up my mess. What I learned as a software engineer, as a magician, as everything else, is that mastery is more than superficial imitation. Mastery is more than just following the steps and recipes. Oh, actually, I'm going to need the cards again later. I'll come back to these. Mastery requires this hidden foundational understanding. And I learned this in my journey doing magic. I learned this in software, that sometimes we can imitate success. But if we want to build that mastery, sometimes we need to go deeper to find those hidden truths, those ideas. Now, years ago, I was made aware of some science in this field. What does it mean to master something? We actually have a scale, and this is the Dreyfus Skill Acquisition Model. It's a path that we progress in our careers, in our lives, and whatever skills that we're developing. And we start as a novice, we don't know anything. And maybe the best that we can do is follow those instructions, follow those little steps, and imitate. And sometimes we'll achieve success, sometimes we'll failure, but even failures are learning opportunities. And I say that with great trepidation because I'm taking some risks today. Things might not go wonderfully. But when we get a little bit of experience under our belt, we move on to the advanced beginner. This is where we're starting to be aware of context, starting to realize that as things change in our organization, in the project, with our teams, we might need to adjust, we need to adapt. We get a little more thoughtful in what we do. And sometimes in our field, that's where we stop learning. And we become an expert beginner because we've gotten very good at operating as an advanced beginner that we think we've mastered it. And we can get stuck there. I've been stuck there before in my life. It's not unnatural. It's nothing to be ashamed of. The most important thing to do is recognize it. But when we move beyond the beginner stages, we become competent. We have better and richer mental models, and we keep practicing our craft, we keep honing, and we become proficient. And eventually, we become experts. Now, for me as a magician, I've spent decades studying my craft. In fact, this is a video from when I think I was 19 years old. I do not look anything like that anymore. In my study, I was reading these books, diving deep into the minutia, and really trying to learn more than just tricks. Because in the beginning, I learned tricks. They were recipes that I could follow. Do this move, do this move, do this move, the magic happens. But in the pages of those books, there was wisdom. And in the beginning, I skipped all of that. That was the boring stuff. Teach me another trick, I said. But I truly needed to go deeper. And eventually I learned that magic is more than moves. See, I remember reading some of those books, and there were magic tricks that I followed all the steps and I couldn't do it. And I didn't think it was possible. I thought, this is filler material, this couldn't be done. And then I realized instead, it was just beyond where I was. It required that depth. It required more than just moves. It required me understanding psychology, audience management, misdirection, intuition. And a lot of these are skills that can't be taught. I can't read them in a book. I can only gain these skills by going out and doing it, sometimes succeeding, sometimes failing. Magic is more than moves, and my breakthrough was understanding the underlying medium and understanding the real problem, not just the tools. The moves were just tools. The frameworks that we have, the languages, they're just tools. But the deeper we go, the more effective that we can become. Now, a big inspiration when I was growing up was this guy, Dr. Richard Feynman, a physicist in the first part of the middle of the last century. Fascinating individual, wicked smart. If you get an opportunity to find some things about him online, definitely worth exploring. I learned a lot just by reading his stories and things like that. And one of the stories that I particularly enjoyed was his challenge with the abacus. So if we rewind time to the 1940s, we didn't have computers as we knew them. In fact, computers were people. If you looked up in a dictionary, the definition of a computer, it would be one who computes. Computing was an occupation because we didn't have good machines that could do general purpose computation. And he was in a diner one day. He was working on the Manhattan Project, and he would go to this diner regularly. And he would have lunch. He was friends with all the staff. And of course, at this point as well, we didn't have the tablet that adds everything up, and you spin it around, and you swipe and tap your card, and magic happens. It was all cash and notepads. People would, there was a little notepad that the server would have, and they would write down your order, they'd write down the prices, they'd add it all up at the end, and a lot of times they added up in their head. Pocket calculators hadn't been invented yet. And the big desktop calculators, they were wildly expensive. You weren't going to find one in a restaurant. So you just had to do that. And a man walks in from Japan, and he's going around selling abacuses. Do you remember these? Little beads on wires, you slide them up, slide them down. You can do all kinds of mathematics with them. And the man was trying to sell the waiters and waitresses these I don't know how to pluralize that word, but we'll go with it. And he says, you'll be so much faster at doing your arithmetic all day. And he wanted to prove it to him. He challenged the servers. Now, they didn't want to lose face. Like, they knew that this guy was going to embarrass him. So he says, you know what? Why don't you challenge one of our customers? How about that guy? Which was that guy. A celebrated physicist who's been deep in mathematics his whole life, never had the benefit of calculators and computers, just got very good with numbers. And they sat down and they wrote out these different math problems. And in the beginning, they were doing addition and subtraction, even fairly complex addition and subtraction. And Feynman was right there with the abacus just doing it in his head. And the guy's like, wow, you're actually pretty good. He was a little bit taken aback because he's starting to think that perhaps he brought a knife to a gunfight. And then he says, let's do some more interesting challenges. Let's do some logarithms. Let's do some cube roots. And they came up with this like 3 or 4 digit number. What's the cube root of that number? And the guy's trying frantically to calculate the cube root of that number, and Feynman just writes it down. And other people are throwing numbers out, and Feynman's there again and again and again, mopped the floor with the guy. And the abacus salesman was stunned. And afterwards, even the waitstaff were a little bit impressed. And he said, I realized something. He doesn't know numbers. With the abacus, you don't have to memorize a lot of arithmetic combinations. All you have to do is learn to push the little beads up and down. You don't have to memorize that 9 plus 7 is 16. You just know when you add 9, you push a 10's bead up and pull a 1's bead down. So we're slower at basic arithmetic, but we know numbers. And that was one of the reasons he was so effective as a physicist, that he knew his field in depth, not just the recipes to follow, not just the steps to follow. Now, yesterday I had the privilege of sitting in this room while James Lewis told us the story of how microservices came to be. And I asked him, I said, I loved your session. How do you feel like it went? He said, well, I think I split the room because there were people who loved it and there were people who were bored. Why are we talking about history? I want to know the latest and greatest of what to do with microservices. And that broke my heart a little bit because as an independent software architect, I get called in to do a lot of rescue projects. And people try to adopt microservices without understanding how they came to be. And when you lose that history, you lose what needs to develop in your organizations. You lose how you need to drive your organization's history. Because we have not all been on the same path in our organizations and our careers. And it was very illuminating. And that's why I call myself a holistic architect, because it's more than just the patterns. Oh, well, this granularity and that service mesh and this computational platform and that cloud service, we put them together, we get microservices. It's an organization-wide transformation. Teams completely change how they work. And I don't think it's possible to really understand that well without either failing spectacularly over and over and over again until it clicks, or taking a step back and saying, this was the path that they took, and I'm going to learn lessons about the path that I need to take. We owe it to ourselves to stand on the shoulders of these giants. Now, how did Feynman get here, though? Because he was very skilled in so many different places. And he discovered how those skills made him more effective in everything else he did. He decided he wanted to travel one day, and he went to Brazil. He learned to play the bongos. He has been on so many adventures. He explored so many ideas. And if you read this book, and I would highly recommend this book, Adventures of a Curious Character. Surely you're joking, Mr. Feynman. You see how curiosity has been at the heart of everything that he did. He realized that everything is fascinating when you look at it through the right lens. And we want to be curious. We want to look beyond, well, what do I need to know today? And ask the question, what can I know? This is a foundation that we can build upon. So I'll do this. I'll build a tiny foundation. But that's just the beginning. I'm going to go deeper into mathematics for a moment. Does anybody know who this is? Yes, Pythagoras. Famous for the Pythagorean theorem, a squared plus b squared equals c squared. That is a tremendously useful little theorem. We use it constantly, day to day. Now it's buried in software code, but we use it for navigation. We use it for communication. We use it for architecture. We use it for design. We use it for agriculture. It shows up all over the place. And people saw how powerful that was, and they said, they wonder if this theorem has any more properties. What happens if we cube the numbers, or take them to the power of 4 or the power of 5? And what was interesting, nobody found any set of numbers where it works for cubes. Nobody found any set of numbers where it works for powers of 4 or 5 or 6 or 7. And people would brute force this. And they kept not finding it. And that led to an interesting question. Are there any other powers beyond 1 or 2? Because it also can work for 1. That makes it super easy. But power 3, 4, 5, anywhere all the way up to the limits of possibility and beyond. Are there any other A's or B's or C's and any combination of powers where this works? And we couldn't find it. And that's a hard thing to grapple with in mathematics because is it not possible? Or have we just not tried the right set of numbers yet? And we know we can't brute force it because there are an infinite number of numbers that we can use. Now, here's another interesting fellow from history, Pierre de Fermat, who read a very old mathematics text. He wasn't worried about what the cutting edge of mathematics was. He was building his foundations. And he's reading this text, and they talked about this conjecture, this belief, this hypothesis, that it only works, there are no positive integers, x, y, and z, for which x to the n plus y to the n equals z to the n for any integer greater than 2, any power greater than 2. They said, we believe this is true, but we can't prove it. And nobody had been able to prove it. Now, Pierre de Fermat had that book, and he wrote in the margin, oh, I've proven this. This conjecture is true. I've proven it. I have a marvelous proof, but it won't fit in the margins of this book. And then he died. People had been grappling with this question for centuries, and they found that they got a glimmer of hope, and they searched every scrap of paper that had ever been associated with Pierre de Fermat, and they couldn't find it. And people talked about this for decades, for centuries. This was the 1600s. And even in Star Trek The Next Generation in the 1990s, Captain Picard says, oh yes, mathematicians are still trying to solve that one, implying that even in the 24th century, we still hadn't found Fermat's marvelous proof. In fact, we solved it not many years after that Star Trek episode aired. Somebody came up with a proof. It was gigantic. It was something like 28 pages. So yes, it definitely wouldn't fit in the margins, but I don't think that was the marvelous proof he was talking about. So either he found a more elegant proof or he was wrong. Either way, we've proven this now. And we call this Fermat's last theorem. Not because it was that one that we were thinking about after he died. There were a bunch of those. There were a bunch of times that he had done this. But all those other ones we eventually proved as well. Fermat's like, oh, I've cracked that one too. And they're like, really? Oh, yeah, he's right. It's possible. I found a proof. This was the last one. This was the one that took centuries to solve. And that's why we call it his last theorem, because all the other theorems we eventually found proofs for. Now, there's a different theorem that didn't get much attention. This is Fermat's little theorem. And in number theory, Fermat's little theorem states that if p is a prime number, then for any integer a, the number a to the power of p minus a is going to be an integer multiple of p. Now that normally doesn't work out that way with powers, but it's a weird little fact about prime numbers. A weird little thing. So what? Numbers do weird things sometimes. It's interesting if you're curious. It didn't get much attention. And then sometime later, we were trying to solve a problem. Now imagine you, sir. I want to pass you a message. I'm going to write something down. I want to pass it to you. Easy. I'll pass it to you. You'll pass it back. You'll pass it back. You'll pass it back. It'll go to you. But there's a catch. I don't want anybody else to read it. That message is for your eyes only. Well, we know what to do. Encryption. So I'm going to write it in a code. So I write my code down. I pass it to you. You pass it back. You pass it back. You pass it back. You pass it. There it is. Except you don't have the key, do you? How do I get the key to you? Well, I could write it down, pass it back, but now you have the key. That's a really hard problem. People had grappled with this for millennia. And it turns out this weird little fact and a few other facts about prime numbers were instrumental in cracking this problem. This is how we got public key cryptography. And this is one of the foundational ideas that makes it work. That you can have a public key and I can have a public key and it doesn't matter who sees it. And we can exchange those keys. We can broadcast. I can put my public key right up here. It's not a secret. But you have a secret key and I have a secret key. And that's what allows you to unlock a message for you that I lock with your public key, and allows me to unlock whatever you lock with my public key. This is powering everything today. And it works because the people who created public key cryptography and those who have come after, they knew their field. They didn't tune out the little details that didn't seem important on the surface. They were curious. Now, here's another example of where knowing your field can be really valuable. The other day I was sitting in one of Ken Sipe's sessions, and he was talking about one of the things he likes to do is ask architects good interview questions and see how they think about the problem. And he asked a question he gave a hypothetical. We built a proof of concept. We're ready to go scale now. Now, in this system, we have a highly normalized relational database, but we need to 100x the reads. How do you solve that architecturally? And we got the same kind of, we got a variety of answers, but some of the answers are the same that he gets in the interview. They immediately said, oh, throw away the relational database. Relational databases don't scale. I beg to differ. Now, there are ceilings to everything. But again, we learned the basics of a relational database. I'm sure most of us could write a select, an update, a delete, maybe an upsert or a merge operation. We know our joins. We got this. By show of hands, how many of you work with relational databases every single day? Almost all of us. How many of you feel like you're pretty good with these relational databases? Okay, that's good. Very few hands. That's honest. Because one of the questions I'll ask is, well, 100x of what? What do we mean by scale? What are we at right now? And how optimized is our database? And I know people who consider themselves to be experts with databases. And they'll proudly proclaim, no, we have to completely rewrite everything. We need a completely different kind of database. We need to figure out how to take our normalized data model and denormalize it, put it in a document database, because then we can do sharding, and sharding is the secret sauce to the web scale soup. And I might ask, do you know how to read a query plan? Because we work with these tools every single day. How deep into this tool do we go into? Or do we just assume that the limited knowledge that we have is all there is to know, and if we don't know how to scale or optimize or tune that database, then we just need to throw it to whatever the vendors are saying is going to be web scale, and that's what we need to do. I saw a t-shirt recently that said this: the first rule of Dunning-Kruger Club is you don't know you're in Dunning-Kruger Club. If you're not familiar, because you might not be, the Dunning-Kruger effect is a phenomenon where the less you know about something, the more likely you are to overestimate your knowledge on that thing. And conversely, the more you know about something, the more likely you are to underestimate your skills in that thing. I am not saying there is anything dispositive here. There are no conclusions that can be drawn because I don't know you. But the people who raised their hand and said, oh, I know the databases really, really well, you might be here. You might be here. This is why I can't tell you the answer, because both of these feel the same. But those of you who didn't raise your hand to the second question, you might be here. This is called the Valley of Despair. But you've escaped the peak of Mount Stupid. You might be here, you might be here. Because what's happening is you learn your subject better, you start to realize how much you don't know. You are taking unknown unknowns and moving them into known unknowns, and that is progress. And of course, if you didn't raise your hand, you might also be here. I don't know. It's very possible. This is the problem with the Dunning-Kruger effect. But this is another one of our foundations, understanding your field. So we're going to build our foundation. And you have no idea how nervous I am trying to do this live on stage. Why not? What a good idea, Carducci. Build a house of cards. Oh, thank you. I don't need your pity. Let's change gears a little bit, get back into the technology field. These are Herb Simon and Alan Newell. They wrote the first artificial intelligence program in 1955. This is before computers could do anything other than calculation. This is still where we were largely programming computers by plugging wires into plug boards. Well, then I wanted to do this, and I need to do that kind of, I need this kind of gate, and then I need that kind of gate, then I need that kind of gate. We knew theoretically programming language could be built, but we didn't have the tools and the hardware yet. And so everybody was trying to figure out how to make these computers do a couple hundred more computations a second. They were busy thinking, I wonder if a computer could think the way a human did. This is a few years after Alan Turing wrote On Computing Machinery and Intelligence in 1950, asking the same question. And they built this tool, Logic Theorist. It was a proof of concept, but it demonstrated that computers could potentially do reasoning on tasks that we thought only humans could do. And then a couple years later, they built something called General Problem Solver, kind of extending this and generalizing this. They stood on the shoulders of giants because one of the challenges was, how do we explore all these possible spaces? Well, right around the same time, Dijkstra was doing a lot of work in searching in spaces and trying to figure out how to do those things. And it was the confluence of different ideas that were unrelated in some cases and putting them together. Just being aware of what's out there. But later on, they wrote a book called Human Problem Solving. And they introduced us to some ideas, some conceptual ideas. The problem space is where the value is in what we create with technology. And the solution space is how we get to that value. I've been extremely guilty of this in my life. Because honestly, the problem's boring. Right? Like whatever the business analysts are going on about, and this and that and value streams, I want to write code. I want to build cool stuff. I want to see if I can make the computer do my bidding better than it did before. I want to play with the new shiny tools. I want to try new languages. I think I'm going to do this functional. I read The Gang of Four, the design patterns book. And I didn't understand that they were solutions to problems. I thought they were just best practices. So for me, after I read that book, oh, woe be you if you were on the same project as me at that time. Because once I read that book, I found a way to use all the patterns in everything I did. I'm like, ooh, this is going to be a singleton, and okay, this is going to be a factory, and I'm going to have the visitor pattern here, and I'm going to observer over there, and so on and so on and so on. I was just wheeling solutions everywhere, and I never bothered to understand what the problem was. But the thing is, the problem that we are solving with technology, that is always outside of the computer, even when we can convince ourselves that it is, well, I'm just building an API for a client, for the developer building that client, for the problem they're trying to solve. And the solution space is inside the computer. It's the technical implementation. It's the new shiny toys that we get to play with. And don't get me wrong, I love the toys. I love the new and shiny. I love learning. I love trying new things. We have this glorious buffet in our hotel where we are privileged to eat breakfast every day, where you had your final masala dosa of the year, probably. And I came here early to set up for the keynote because I was nervous. So my final masala dosa was Monday. Missed opportunities. But actually, I lost my train of thought. Thinking about dosa. Realizing perhaps I should not have skipped breakfast. But I was down here, and I don't know where I was going. So I'll just keep going. But I was down here preparing, getting things ready. And yeah, I really wish I knew where I was going with that. I'm not sure how to segue now. But speaking of segues, this is a book by Michael Jackson, not that one, the other one. He wrote a book called Problem Frames. And this is where I learned these concepts. This is where I learned the concepts of the problem space and the solution space. And he had some very insightful things to say in this book. He said, we software developers have built up a reputation for solving the wrong problem because we get so caught up in the solution space. And again, don't get me wrong, I love the solution space. Oh, that was my point. It's come back to me. Don't lose it. Hang on to that, Carducci. I love trying new things. So we have this glorious buffet in our hotel, and they have dishes from all over the world. And they're fantastic. And every single day I go into that buffet. Now, there are the things that are familiar. that I might eat in the US for breakfast: eggs and bacon and toast and pastries. Boring. I can get that anywhere. And then there are the things I love, like the masala dosa. This is why I only had a masala dosa on Monday. Because even though I know I love the masala dosa, every time I walk in there, all of the options are different. And I look at something, and it has an unfamiliar name and a very unfamiliar look. I have no idea what this thing is. I'm going to try it. I love the new and shiny thing. But when we get caught up, we lose sight of what the problem is. It's Michael Jackson who said the problem is always outside the computer, the solution is always inside the computer. And if we spend too much time looking at solutions, we tend to solve the wrong problem. He also said, for many people in software development, the computer remains far more interesting than the problem world. I think I just said that. And the problem is not at the computer interface, it is deeper into the world, further away from the computer. And this is a skill that I had to learn. I could not be an effective software architect. I could not master software architecture until I learned that you don't drive the architecture requirements, the business does. You don't drive the architecture, the business requirements do. And we just do our best to serve their needs, which means to be effective. You have to understand the problem. And the whole first section of the book is really diving into that piece. And my biggest fear is people are going to buy this book, read this book, they're going to skip past all of that to the interesting stuff about cutting edge architecture models. And they're going to miss the value. So my next foundation for you, is to understand the problem. We have another thing that's been talked about quite a bit today, or this week, MCP. We saw a ton of agent proof of concepts, and they show this way of being able to connect a language model to another system or a data source and do cool stuff. But they focused on the solution, not the problem. The problem isn't coming up with an interface definition language, an IDL, which is what they've done here. The problem is integration at scale. So we've got a great proof of concept. It's a half step in the right direction, but let's call a spade a spade. Looking at that architecture right here, it's very close to REST, but not quite. And looking at their interface definition language, anybody who's been around as long as I have, this is starting to feel familiar. It's starting to feel like we've seen this movie before. It feels like a JSON WSDL. Now, if you don't know what a WSDL is, lucky you. But unfortunately, those who don't pay attention to the past are condemned to repeat it. So you're going to get the next generation WSDL built by those who went around the first time we tried this and it failed. It's half of REST, the least useful parts of REST, and the least useful parts, and some of the interesting parts of SOAP put together. It's not great. And it's also fundamentally missing another point. The input schema, what is it? It's an object. It has a title. What does title mean? Could be the title of a book, title of a song, a job title. Could be an honorific, like doctor. Could be a title of nobility, like lord or baron. It could be the subject of a ticket. And we're hoping that we're building documentation good enough that the language models can take a probabilistic guess and some percentage of the time guess correctly because we're wanting to get determinism out of non-deterministic systems. But that's okay because we have the input schema. What does title mean? It's a string. So is body. What is labels? It's an array of strings. There's no semantics. And I get it, right? The philosophy of language. When I was growing up, I thought philosophy was boring. I did the minimum that I had to do so I could pass the class and never take it again. Now I find it fascinating. I read things like this, Übersinn und Bedeutung. I pronounce it for yourself, I don't know. This is a paper from 1892 by Gottlob Frege. This is arguably the most important paper in the history of the philosophy of language. And it's very complicated. People spend their entire careers trying to understand this paper. But what it points out is that language is hard. Words and language have multiple levels of meaning. And this laid the foundation for a set of tools to understand language and define explicitly semantics, terms and what they mean and how they relate to each other. Now, we did a really good brute force attempt at it with language models. They work amazingly well. But trying to do large-scale integration to make this agentic vision truly possible, not just building a bunch of point-to-point middleware, the way we've done integration forever, the way that we have not been able to keep up historically, and it's only going to get worse, by ignoring that fact, we're going to hit a ceiling until we try to solve the real problem. And this is another foundation that we can't ignore. We need to do the work, the boring work, the tedious work, to understand what the real problem is. Because only when we understand the problem can we solve it. It's not exciting until you get excited about the value that you're creating. I talked about the book. I don't need to talk about the book anymore. I got ahead of myself there. But there's something oddly prescient in this paper by Fred Brooks, another giant whose shoulders we stand upon, that regrettably fewer and fewer people know who he is, because his words, even though he published this paper in the 1980s, it is just as relevant today as when he wrote it, if not more so. This is no silver bullet accident in essence in software engineering. But fascinating paper, read it, it will expand your mind. Because one of the things I realized by not understanding my foundations, by not understanding the problem, things just got more complex. We created accidental complexity. There's essential complexity. This is the part of the problem that is just hard. And then there's the accidental complexity. It's all the stuff, it's all the places where we make it even harder. My homework for you, it's a short paper. Read it. Learn who Fred Brooks is. But Fred Brooks is one of the giants whose shoulder I stood upon to write this book. And Roy Fielding, and Perry and Shaw, and Mark Richards, and Neil Ford, all these people. So let's build on our foundation. Because software architecture taught me that everything is contextual. And so let's build on our foundation with contextual decision making. There are no best practices in software architecture, only trade-offs. Everything is in context, including semantics. This is how we build our career. This is how we build ourselves. Because what does expert mean? I'm a software architect. I wouldn't call myself this, but people have called me an expert software architect. How can I be an expert? This is my friend Justin Rourke. And this is a slide which is a layout of all the different tools and technologies in the cloud native computing landscape. I haven't even heard of half of these. How can we know it all? How can we call ourselves an expert? I think true expertise is continuous growth. I remember once I worked with an engineer who made a mistake. And actually was reviewing something that I'd optimized. And he's like, oh, let me take a stab at it too. And then he de-optimized it. And I said, I see what you're doing there, but you think the problem is that I'm using a temp table in this stored procedure, but that's not really the problem. The problem was this operation was way too slow. And yes, you've gotten rid of the temp table, kudos, but now you're iterating over the data set. Relational databases are optimized to work on sets of data and do transformations on sets of data. When you do it row by row, when you think about it like a program and do loops, you're slowing it way down. You've just gut punched the query optimizer and taken away all its magical tools. And so I said, well, this is I probably could have phrased it better. I get frustrated sometimes. We all do. But I sent him some resources online to read further to kind of support some of the things I was saying. And he says, I've been doing this for 10 years. I don't need an article on the web to tell me how to do my job. I got a little upset by that. We need to be always learning, always growing. Because otherwise, we might be an expert beginner. We've gotten so good at being a beginner, we trick ourselves into thinking we're an expert. So embrace continuous learning, intentional learning. Mastery is a journey, it is not a destination. I had a great conversation with a delegate here, and she says, I really want to get there. And I said, there is no there. And I knew she knew that, and that wasn't her express, but it was an important thing to understand. I'm going to say it again today. There is no there. We are either growing or we are decaying. Those are the only two states. But Justin's problem statement shows us that we live in an abundance of information. And we know we can't learn it all. What we have to realize is that throughout all of human history, information was scarce. You have a book? That's amazing. Can I see it? And today, I have a shelf full of books I haven't gotten around to read yet. They just sit there and loom on my shelf and make me feel guilty. We have access to the sum total of all human knowledge in our pocket. And so in an age of information scarcity, hoarding knowledge is key. But in an age of information abundance, we need to develop filters. And we can only decide contextually what to filter by understanding the problems that we need to solve and understanding what is directly related to a problem, what is something foundational that we are going to take across disciplines and throughout our careers, even as everything changes around us. So we now have another advancing foundation. And my goodness, is this getting tense? I'm shaking. I'm just going to put this capstone on with the hopes it will steady my structure. And now we are here, embarking our journey on the last day of the conference. And we're going to be growing and we're learning. And we came here today excited about operating at the vanguard, about the tippy top of our career, working with the latest, the greatest, the cutting edge, building cool stuff. And oh, thank you. And I want this for you. And I want this for me. I want this for us. And please, be the vanguard. Push the envelope. Take risks. But my caution to you is do not neglect your foundations. Do not get so excited about the future that you forget the past. Do not shy away from standing on the shoulders of giants. Otherwise, it is all a house of cards. My call to action: seek deep understanding of the problems before the solutions. Broaden your foundational knowledge. That's what you take with you. I know you've changed technology stacks or frameworks before, and we're going into the age of AI, and there's a lot of uncertainty. But you already know, if you've changed technology stacks before, then you know that there are skills that you have that transcend that you carry forward. So that, and even the seemingly irrelevant stuff, because if it's in your field, if it's the stuff that lives on, like the ideas of relational database haven't changed. The foundations of distributed systems haven't changed. And we learned most of the lessons in the 1970s. So don't be afraid to look backwards, because this stuff is still relevant today. Embrace your role as intentional architects of technology, particularly with all the AI evolution. Embrace continuous learning. I'm so glad you're here, because that is what you're doing right now. You're continuously learning, but don't neglect to take time to invest in the foundational concepts and the timeless concepts. And mentor other people with your foundational thinking, and you can become a giant yourself. If you want to read more about the ideas that created the future, some of the giants whose shoulders we stand upon, this is an outstanding book. And I've got a quote from the introduction: the collection came to be to help readers see how important new ideas came to be, how tentative, clumsy baby steps became graceful, progressive strides, or how sometimes ideas go nowhere for years and then they're taken up after a long delay. There are, I promise you, in the past decades of our field, ideas that were ahead of their time and they were ignored, that are absolutely relevant in this moment right now. Discover these, utilize these, and be that giant yourself. And I'll leave you with these immortal words of R. Buckminster Fuller: we are called to be architects of the future, not its victims. Thank you. Thank you.
Thank you so much for that, Michael. Let's give him one more round of applause, shall we?
Oh, yeah. Oh, yes. We're going to take a quick photo. You know, let's do something fun. Can I get everybody to stand up? indulge my vanity, if you will. And please, for the photo, one more round of applause. Thank you. Thank you so much.
Thank you, everybody. Thank you, Michael. I never would have found myself otherwise surrounded by incredibly magical people. Magical people like you. Any sufficiently advanced technology is indistinguishable from magic. There's a piece of glass that is in my other pocket.
There we go.
Look at this thing. If I touch it a certain way, or if I look at it a certain way, I could have a pizza show up on my doorstep. Another swipe of my hand, I can have a car show up and it'll take me anywhere that I want to go. That's nothing short of magic. There's truly magic standing on the shoulders of giants. And our next speaker is going to be talking about a different kind of magic. You bring the code that brings the magic. You stand on the shoulders of giants that bring the magic. He's going to be talking about the kind of magic that you can do in your organizations by building bridges, expanding your skill sets. Please help me welcome our next speaker to the stage. We'll be talking about creating connections beyond code, Nicholas Kontopoulos. Give him a round of applause.
Beautiful, functional, or make a difference? Will it change the way we work, or simply bring us together? Whatever it is, it needs to be better. Better for business, for people, for our future. It has to be smart and connected, however people use it. What will I build today? An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. I need freedom to think, to imagine something the world didn't see coming. Because I'm not a talker or a philosopher, I'm a doer. I don't wait, I build things that others can't imagine. It's not something I choose, it's just something I do, something I am. I have to build, be bold, try. Only then will I make a dent, make a name for myself. And today's the best day to start. What will I build today?
Hi there. Hi there. As introduced, my name's Nicholas Kontopoulos, and I've got the great pleasure today to talk to you about a topic I'm deeply passionate about. And Michael set up, actually, there was a little bit of magic occurring between Michael and I, because we never actually met before, and a lot of the points he's made I'm going to bring through in my talk today. So thank you for that amazing presentation today. My name's Nicholas Kontopoulos, and I'm going to start off by pointing out one thing. I'm not a developer. I've never been a practicing developer, although back in 1987, I went and tried my hand at coding at IBM as part of a work experience program, and I quickly found out I wasn't smart enough to be a coder. But what I have had is an amazing journey through my career where I've worked with talented and amazing engineers and developers. And one thing I have a passion for is customer experience. And when I think about the transformational projects where I've seen significant change being delivered, it's when there was a genuine partnership between the CX professionals and the IT department supporting us in driving those changes forward. So that's going to be a key theme for my talk today. And if I think about 1987, when I first went out and tried my hand at IBM, a lot's changed. Technology's evolved, the way we build our buildings, the media, our own consumer and employee behavior is constantly changing. The products we interface, the form factor, the content, the way we consume that content, the way it's served up to us constantly changes. And that's what makes all of our jobs so exciting. There is never a dull day in what we do. If I think about also the very idea of developer has changed from the early days in 1987 when went out and explored what that world might look like, a lot has changed. The tools developers use have changed. The actual roles you perform have changed and continually evolve and change. And it's a really exciting space. But who is behind all of this change? You guys are, the developers. You are the pioneers of that change. You are driving that change. Developers are ultimately some of the greatest creators of customer experiences that we know today. You ultimately have the power to shape digital experiences that customers experience each and every day. And you don't have to look far, as was alluded to earlier. In our pockets are most probably, if not all of these apps, or one or two of these apps that we use. And these brands ultimately reimagined the way we were ultimately interfacing with, well, actually they disrupted industries completely. And how did they do that? End of the day, brands like Uber, Airbnb, and Netflix reshaped those industries through reimagining the customer experience. And that was at the heart of what enabled them to disrupt those industries. It was developers ultimately who actually thought about how they could disrupt that, wrote the code that connected riders to drivers, engineered the trust layers that made strangers feel comfortable in using someone else's house, and ultimately even helped create the term binge watching through the way that we ultimately now consume content on Netflix and other platforms like that. So you guys were at the heart of driving that change. I'm going to quote here Imbal, who's our Chief Product Officer, and I really like, she wrote a beautiful article which I'm going to share a QR code to in a second. I really encourage you guys to go read it. She talks about AI and how it's reshaping the world of developers, shifting the focus away from pure code generation towards systems designs and architectural thinking. In large-scale systems, how components and subsystems interact often will be more critical to success than the individual lines of code. So I'm going to challenge you guys today to think beyond just the code and think about how you interface with other parts of the business. How do you identify the problems that need to be solving? How do you ensure you're not treating a symptom versus the actual problem? And how do you work with your different business partners to ultimately build the technology capabilities to overcome those problems, as we heard Michael talk about so eloquently earlier? So if you want to have a read of this article, I really encourage you to take a quick scan of this QR code. It will take you to the post. It's a fantastic read. It was almost like Imbal and I were thinking the same thing when I was preparing for this conversation, for this discussion today. Again, I think we're going to share the PowerPoint deck later with you guys, so if you don't get a chance to capture this, don't worry, you can share it later. I'm going to also position that you guys are modern-day digital Michelangelos. You are the architects of the digital experiences that each and every one of us experience each and every day. I really do believe that you guys are crafting experiences, not just code. You ultimately are obsessing over the flow, the finesse, and ultimately the feeling that we ultimately experience as consumers when we interface with these different tools, or as employees that interface with the tools that you guys are helping build. You didn't just write code and develop applications, you sculpt experiences. Really think about that. That's really at the heart of what you're helping drive and power. Developers aren't just building applications, you're ultimately shaping the entire customer journey. Whether it's from the first interaction, from that first moment I download an app and verify who I am, right through to the post-sale engagement and beyond. Great customer experience happens with every one of these interactions, feels effortless, relevant, and personalized. In actual fact, I'd argue now we can move beyond personalization to individualization. How do we individualize the experiences we're delivering to our customers? Well, one of the biggest hurdles that sits in front of us, and in my experience in being part of digital transformational projects that was CX focused, is the siloed nature of our organizations. Gartner coined a term, dark data, which I absolutely love because it is representative of the real problem we have when it comes to solving for some of the problems that we want to tackle. Dark data basically being all the data that's trapped in the different operational silos, whether it's marketing or customer service or logistics, supply chain. So part of the way we need to solve for modern day customer experience challenges is looking at how do we harness that data that sits across the enterprise. So how do we create better customer experiences then, Nicholas, if this is a real challenge? Well, I'm going to argue and this is based on both failure and success in my career, that the best customer experiences are born out of cross-functional teamwork. It's born out of a passionate tribe of people coming together across different functions and working on identifying what the root cause of the problem is versus the symptom, and building solutions that ultimately will enable us to deliver and reimagine the customer experience we want to achieve. Think about it. Anya here's, started her journey making, browsing a website. Ultimately, she abandons the cart. She receives an inquiry or makes an inquiry with an AI chatbot. Ultimately, she's interacting with these different channels, that each channel connected in a way that enables Anya to actually have a frictionless experience. This is born from ultimately this is only achievable if we see the organization working together in addressing the challenges that occur, identifying the real moments of friction that we want to remove in that journey, and working together to really understand how do we use technology smartly to solve that problem. I'm actually a big fan of Steve Jobs' quote, "Start with the customer experience and work back to the technology." Such a beautiful, beautiful quote to have posted on your wall or on your desktop as a reference point. These interactions that I just showed made Anya feel valued. Ultimately, her problem was solved. But developers worked hard behind the scenes to make this seamless. So again, it's you guys in this room who are going to be helping solve these issues, working with your partners in the business in identifying how do we make that frictionless journey become a reality. Twilio, obviously, as a company, is very passionate about communications and customer engagement. We were born with a sole mission when Jeff Lawson started the business to look at how can we help remove that unnecessary friction, how can we use digital tools and provide those to developers in a way that enable them to build capabilities that could give that same type of experience I just showed with Anya. We see builders as having a purpose as designers of customer experience. We don't just think you guys write code. They write code for a reason, shaping how the customer feels when they're embarking on that journey with your brands. And ultimately, you think about the channels today that are available. There are so many channels, and we need to look at how do we remove unnecessary friction and ultimately create a channelless customer experience. Ultimately, we need to look at how do we bridge that gap that occurs between the different silos in the organization, and ultimately we provide a set of tools that enable you as developers to work with your business partners internally to ultimately solve for those issues. But here's my challenge to you. I want to give you a challenge. Ultimately, you need to take ownership beyond the code. I think a lot of what Michael spoke to this morning, connected with me for this very reason. You need to be working with a tribe of internal advocates, identifying folks that share that passion, share that vision of what needs to happen in order for transformational change to occur. You need to think about how you work with your support teams who rely on you to make customers' lives easier, product managers who see you as a strategic partner, sales teams who are on the front lines with prospective customers. How do you arm each of these individuals with the capabilities needed to have meaningful conversations and to deliver on the brand promises that are being made? So really ask yourself, what can you do to strengthen these relationships when you go back after this amazing week? Build a tribe within your organization involves thinking about having empathy for your end customers, but also your internal customers, those business partners you're going to be working with. Look to influence CX decisions and roadmap planning. Look to encourage the business to really understand what is the art of the possible with available technologies. Build trust by ensuring technical solutions ultimately do deliver against the promises being made. Amplify your ideas. Again, building tribes enables you to spread those ideas that you have and influence the organization and ultimately help drive the transformational change that's possible. So what does good tribal leadership look like? I'm going to turn to Spotify here as a great company that I think has a fantastic approach to how they build out cross-functional teams. They call it the squad model. And they bring cross-functional teams that has developers, designers, product owners, business stakeholders all coming together, really working together to really solve those real-world problems that their businesses are facing, be it their actual customers or their internal customers, because it's not just about customer experience, it's also about employee experience. How do we create the tools that enable our employees to deliver consistently on the brand promises we're making to those customers. These two books, I'm going to give you a little bit of homework. These are from Seth Godin. Fantastic reads. They really influenced me. He's a marketer. You might be going, oh my God, why would I want to read a book from a marketer? But they are fantastic books. So the lessons from this really, I think, are cross-functional in terms of how you can build tribes and ultimately look at how you can get your ideas spread across an enterprise. So I really encourage you guys to read that. Embrace your role as an architect of experience and a connector of teams. I really want you to be part of a revolution that you can drive within your organizations. You design the bridges that connect customers to brands that they trust. Customers don't just use technology. They rely on it. So this is a really important point I want to bring home. And ultimately, at Twilio, we're very passionate about the idea of being builders. You are builders. And collectively, we can build together. We love hard problems. Another point that Michael touched on, which I couldn't agree more with, is harness that natural curiosity that each and every one of you has. Use that to power how you identify challenges that you can ultimately build solutions to. But equally, be owners. Make sure you take ownership of driving those teams forward and helping provide that inspiration and passion that's needed to power through those hard moments. And ultimately, to do this, have empathy. Be a positron. Harness that collective capability within the organization. Channel that collective knowledge and work together to ultimately drive to a positive outcome. At Twilio, these are 4 core values that really power what we do, whether you're a developer working for us or you're a developer working with our tools within your customer base. So, at Twilio, again, just the last bit of pitch in terms of our products, we deliver a set of capabilities and tools that enable you to reimagine the way you can architect customer experiences, whether it's messaging, voice, email, video, authentication, contact center capabilities. We have a set of tools that enable you to reimagine Anya's journey I showed earlier and actually deliver that in your organizations. But technology itself isn't a differentiator. It might sound odd for me to say that as a marketing leader for a technology company. You are the differentiator. Everyone in this room today is a differentiator. It's your creativity, your passion, your empathy that will enable your businesses to drive a meaningful change in how they interact with their customers. Your passion and building skills, your curiosity, your ownership, your commitment to customer experience. These take a set of tools and ultimately enable you to drive transformational change at scale within an organization. So think about when you craft frictionless customer experiences, you're not only helping customers that are interfacing with that brand, you're helping a small business actually evolve their ability to serve those customers. When you build a real-time support, you are giving anxious customers peace of mind. When you connect fragmented systems, you're in a single customer journey, you're restoring trust in that brand. These stakes are human. Behind every API call is someone waiting for a delivery, someone hoping for an answer, someone trusting that you're going to deliver against a promise you've made. So I challenge you to step fully into your role as architects of experience. Be bridge builders inside your organization. Get curious and enable innovation. Be an advocate for customer delight. If you can do this, you can really change lives. You can reshape how businesses ultimately organize themselves around customers, and your impact is a lot bigger than you think. So for those that would like to learn a bit more about Twilio, there's 2 ways you can do this. We're going to give away a free credit for you guys to go in and try out our platform. So there's a $20 US credit. If you don't get a chance to scan now, because I'm up in time, come to our booth where you can actually get access to that credit so you can go and start playing around with our technology. So with that, I want to thank you for taking your time out and listening to me today. Cheers.
Nicholas, everybody, thank you so much.
Thank you.
And honestly, I want to relate a personal story to Twilio. I know Twilio is so much bigger and moved so far beyond where they started. But I remember it was over 20 years ago. Devices like the iPhone were just a dream. And in my small company, we were trying to do something like Uber, but for field engineers. And we didn't have iPhones. We didn't have 3G or 4G or 5G. We had GPRS. We didn't have mobile devices like Android or iOS. We had Windows CE. It was a dark time. I found the hardware to build a GPS receiver, but all it did was give me a bunch of numbers over the serial port. I had to do all my own GPS math. I had to write my own GPS library. And that paled in comparison to how difficult it was to send text messages programmatically. We had a server in a room with 6 Nokia phones plugged into the serial port with really ropey device drivers that we built to send it signals to get it to send messages. And when I first discovered Twilio and their early entry in the market, they do so much more now, but their early entry in the market, how effortless that made it. They were truly one of the shoulders, they were truly giants whose shoulders I stood upon. And they are just continuing to thrive and delivering value in so many different ways, so definitely check them out. And now we have yet another giant, a real giant. I had the privilege this week of having a long conversation with the folks at the Work in Finland booth. When I look back on my life, one of the most impactful things I did that I didn't see at the time was at 14 years of age, I moved from the US to the UK, to Europe. Or Europe at the time, not anymore, but Europe-ish, Europe adjacent. I moved to a different country, a different part of the world, and it changed everything for me. At one point I thought it was permanent. It turned out to be for about 10 years, but it really shaped who I was. And it's incredible what the Finnish government is doing to create opportunities like that for us. And they've brought a phenomenal guest speaker. And this is what I mean by giant. Professor Jouko has served as the Dean of the School of Science since 2016, as Professor of Computational Science at the Department of Computer Science, School of Science. He's the author of over 100 peer-reviewed publications and has supervised or co-supervised over 20 PhD theses. Those papers that created the future in that book that I alluded to, this man has been guiding the next generation of people to creating more of those ideas that create the future. So my friends, please join me in giving a warm welcome to Professor Jouko Lompian.
Thank you. Really happy to be here sharing with you some thoughts about the current AI development. So as introduced, I'm Jouko Lompian from Aalto University, Finland. I couldn't resist going Ghibli style as 500 million other people also. So what we are talking today is that there are views of the AI that one view of these language models is that they are just word guessing machines that produce something that looks like reasonable but has no sense, no actual mind or meaning, no truth. So they are like working like zombies, behaving like humans, but without real mind there behind it. Well, in a way, that's true. They work like this. And another view is that these current models are like geniuses, so they know more than any individual person currently can know. They can speak hundreds of languages. They have undergrad or postgrad level skills on almost all disciplines of science. So they can do coding, they can do very many different languages. So they are like geniuses, and they can make really wonderful things. And in a way, that is true also. So those both are true views of these current AI models. Let's see what I mean by this. First, a little bit of intro that AI, all the fuss is about LLMs, large language models, and generative AI. The AI is much more than that. There are discriminative models like classification, for example, self-driving cars. generative models, basically what they do is they build a statistical model of the training data. And they produce data that resembles the training data. Technically, they draw samples from the joint probability distribution of the training data. Like LLMs, GPT, Llama, and there are like half a dozen others, big models. Diffusion models like DALI and Stable Diffusion, Midjourney, that generate samples of images from training data, or large multimodal models that work with voice, images, and text. Then there are predictive models that forecast future values or outcomes based on historical data. For example, AlphaFold, which predicts the structures of proteins. And they got a Nobel Prize in chemistry last year. And of course, generative models can be used for prediction also because it's all about producing some kind of conditional probability distribution and then analyzing that distribution. And then Gaussian processes that are a bit simpler machine learning tools, but they have advantage that they have very, very clear confidence estimation. So it's an AI that knows when it doesn't know. It's this Dunning-Kruger issue that Michael was also talking about. It's really a big problem in AI that it's currently they are really lousy in knowing what they know or what they don't know. So they are all over this Dunning-Kruger curve. And then there are other, not so architectures, but more like training paradigms, like reinforcement learning, which is like learn to make a sequence of decisions by trial and error. And this is often used in robotics, adaptive systems, decision making, and also in these reasoning models of LLMs like GPT-O or DeepSeek-R. This reinforcement learning is used for guiding the step-by-step solution of problems. So they use this to choose what to try next when they try to solve problems. But let's look first what goes wrong with AI and why. This is from very recent paper from Google DeepMind earlier this month, from approach to technical artificial general intelligence, safety and security. And their categorization goes like, there's 4 categories. One is user as an adversary. AI is used in a malicious way. And this goes with all the technology, starting from hammer. Hammer should be used for hitting nails, but you can hit other people's skulls with it also. And another is misalignment, which is that AI system takes actions that it knows the developer didn't intend, but does it anyways. Of course, there you can yell Skynet, because all this Skynet and Terminator is in that direction. But simpler example is that I ask AI that, okay, I need to cross the road here outside this conference venue, and this traffic looks really scary. What to do? Okay, no problem. Close your eyes and run. And then another category is mistakes. And this is because the world is complex, we have only incomplete information of the world. So whatever model we have, unless its working is confined in a very limited scope, if it is meant to be wide scope, it always makes errors. And this is the biggest kind of fuss currently, these hallucinations and all this issue that AI gives clearly nonsense or stupid things, non-factual answers. And then there are structural risks, and there are several AI agents that work together. This is more about artificial general AI thing. But let's go forward with this. Let's look at the aims for AI agents. And one of the main aims is that these AI agents should work like humans. We often discuss on Turing test, can we distinguish the AI agents from humans? And of course, humans can be creative, very good in math and problem solving. They can be collaborative and all this. Humans can be also greedy, selfish, power-hungry, deceitful. So I'm not sure if human is actually the best ideal for these agents, but since we don't have any other benchmark where we know that there are very high-level cognitive skills for general problem solving, so that's why what we are going towards is this human-like behavior. And then it is difficult to curb then these negative parts, which humans and all the stuff produced by humans also easily contains in these models. And another aim is AI agents should make no mistakes or errors. But now hold on, is that something that characterizes human activity? If so, I'm not human, I make errors. And here we can actually cite 2,000 years back ancient Romans, errare humanum est. It was already clear paradigm at that time. So we make errors. Which one should we choose there? To make no errors, to have error-free, or human-like? Well, basically, we can't go error-free for general models in real world with incomplete information. This is clear. So this is not achievable. This infallibility or zero error is not achievable. It can be done in certain scopes, like some kind of reasoning problems. You can do good reasoning, and you should avoid some type of typical problems that humans also do. But in general, that's not doable. The other end of this continuum is total nonsense or random guessing where there's no truth at all. And now humans can somehow operate on this continuum. So given that we know that we don't know, and we know when we know, and this is not really clear with all the people, as we have seen also before. But so we can operate on this whole continuum. Sometimes we work on very formal, strict, like way of reasoning. Sometimes we go all wild in creative thinking. And so I think what really needs to be improved in AI is this kind of awareness of this internal uncertainty, so that the same model, while it's working in different stages of the problem solving, it can then shift there along this continuum, and at the same time keep track where it is there to avoid these Dunning-Kruger effects. Now, if you look at these mistakes or hallucinations, actually hallucinations is not really a good term. It would be in neuroscience that would be confabulation or memory mistakes. So, but of course it comes from these image generation models where this hallucination which is perceptual failure, they were more like perceptual failure. Now what generative AI does, it produces probable output given the prompt and training data. And because it is probable, then it can't be, again, guaranteed to be error-free. The training objective is probable, the drawing of the sample is probable. And those who were around using this in GPT-2, for example, there you could adjust this parameter, temperature parameter, to also play with this, how repetitive versus how creative and also nonsensical it was. And this is also why there's no concept of fact or truth inside this model. It's just probable or likely, looking like true, but nothing actually related to truth. This is also why this is sometimes called bullshitting. And difference of lying and bullshitting technically is that when you lie, you know that you are not telling the truth. But in bullshitting, you just don't care. and so this is what these models are doing. They don't care. they are just working on this probability scheme. What can we do about this? Actually, exactly the same that we can do with humans. If somebody says that, I know exactly how this goes, what do you say? You ask, how do you know? Where did you read that? Where did you learn that? So this grounding and retrieval augmentation, this is what the current models, many models do. They get back to the references and show you the references. Or uncertainty estimation, Bayesian sampling, meaning they know if they are uncertain. Or ensemble methods, meaning second opinion. You have a number of these models, and if this says something, if many of them agree, then it is more likely true. Another question, how smart is AI at this point? Since I said that they are a bit like geniuses. Well, we don't actually know. We have seen that they can get in the law school, they can get out from the business school. Currently, they can also graduate from medical schools and law schools. But is it really smart yet? There's also very recent result earlier this month where these mathematical reasoning models were tested on completely new mathematical problems that definitely are not in the training data. And the result is that these models are lousy. These are really bad. They don't scare pretty much any points there, which means that actually they are not really smart problem solver, but they are memorizing a lot of samples, and if the next question or problem is similar enough, they can do a bit of adjustment and work like this. This is how many students do, of course, for exams. They are reading a lot of previous exams, and this is what these are doing also. So we need to do a lot of work more in this reasoning part. And is it creative? Now there are two types of creativity, artistic creativity and what we need in science and engineering and entrepreneurship and all this. In artistic creativity, we need to ask artists, and World Economic Forum did it, and the result is that this community thinks that, okay, these methods really do this kind of artistic output. I don't know whether there's more about these methods or the artistic community, but anyways, these methods are there now. This is the famous picture of AI image that won a digital image fair. But is it creative in science? Now, if you think of the hypothetical deductive model of science, this creativity is a process. You make a hypothesis, which is a plausible hypothesis. You don't know whether it's true or not. Then you think, what if this is true? What can you observe? Then you do the observation experimental part, and then you repeat. And actually, this hypothesis generation is exactly the same thing as this hallucination, making probable solution that you don't know whether it's true or not. And actually, the other chemist Nobel laureate, David Baker, has used this extensively for creating new proteins. His group has created 10 million new proteins with these technologies. Okay, and okay, my time's up, so I use only 10 more seconds. In Finland, in Aalto, in Finnish Center for AI, we are doing AI research exactly on this domain. So for real use, for also industrial needs, in the case where there's domain-specific issues, insufficient data, proprietary data owned by several parties, compliance requirements that requires that you need to know how certain these are. So these plug-in models don't fit there. We have to build specific models. They are based on these general frameworks. Okay, thank you. Thank you for your...
Thank you, Professor Yoko. And you're absolutely right.
Yeah.
That is where you are doing the real work, the real innovation for the future. Give him one more round of applause, everybody.
Yeah.
And I will now hand things back over to our main hall MC, somebody who's essential in helping me get the keynote ready this morning. Give her one more round of applause, everybody.
Okay.
Thank you for all your help. I will hand everything back to you.
Thank you, Michael. I really appreciate that. And I appreciate all of you. We are in the last day of GIDS. Go make it the best day yet. We are breaking for a coffee break right now. The sessions will be starting at 11 a.m. And do not forget, we're going to be doing that book giveaway right before the panel discussion. So get in here a little bit early. Leave early to arrive refreshed is what we like to say. And maybe you'll win a free book with our little pop quiz about GIDS. Thank you so much. We will see you all soon.